The moon is a rugged place. In order to create a sustained presence on the lunar surface, we need to be able to create roads, landing pads, and foundations quickly and efficiently. Our approach to lunar site work allows a user to input a specific area to be leveled, smoothed, and graded. Once in place, our vehicle manipulates terrain and moves through the environment so that it can make things flat. Here you can see the histogram of heights from the fit plane before and after operations. This pre- and post-grade height map of a 1-meter crater shows how much we're capable of getting done in a short amount of time. At the heart of our efficacy, software development, and systems engineering is the work system. This work system was built upon scavenged hardware from previous planetary robotics projects. Our low-level motion controller subsystem was built from the ground up in ROS2. After making many mechanical improvements, we also designed a 1 degree of freedom actuated blade, which pushes soil. This was inspired by motor graders that operate here on Earth. Our localization subsystem gives us vehicle pose within our worksite. The information plotted on the right is 2 time distance of arrival beacons mounted onto our vehicle, giving us XY position and also yaw. Another way we get heading is our simulated sun sensor. You can see the April tag in the back acting as our simulated sun during a bench test. We also do dead reckoning with a double kinematic bicycle model in order to get an understanding of what our position is from our wheel encoders. Finally, our IMU gives us roll, pitch, and linear accelerations, which closes out the localization subsystem. All of this data goes through an extended Kalman filter to be fused for our final position. A stereo camera mounted on our sensing mast gives us our perception data for the terrain morphology as we drive. All perceptive data outside of our specified worksite is thrown out. After a few more perceptive layers, our robot is almost ready to be used as a teleoperated work system, but we still have to look at tool control. Here you can see an early attempt at getting a slip estimate from our localization subsystem in order to do blade control. Here you can see a remote teleoperator trying to level a 1-meter crater using only the data that you can see on screen, which is the pose, the perceptive data, and the tool position. The tool is moving completely on its own, independent of operator input.